Today, so in section P4, factoring polynomials, today we work on trinomials and grouping. We're going to do grouping as more or less part 2 of this lesson. So for today, we're going to work on trinomials. So how do you factor something with 3 terms? That's the goal for today. So what if, we look at something, it doesn't fit all our special patterns, how do we factor that? To be honest with you, this usually goes best when I approach it as unfoiling. So your warm-up for today is just to foil. Or expand, it says. Expand means the same as foil. So if you want to take just a few quiet moments, foil those up for me, and then we're going to begin a little bit of factoring here in just a minute. I'm sorry.
Like it was warm last year this time.
Answers to your warm-up. You're going to take a second, check them. Did you check them? They look good?
Yes.
Awesome. On to the next. Okay. Quadratic and standard form. Your friend and mine. Fill in that blank right there if you haven't done so already. Y equals ax squared plus bx plus c. Keep in mind a can't be 0. If you let a equal 0, you have a line. It's not good. No. Do you have to know what a, b, and c are? Yes. So what you need to pull out of this little bit here, a, we call it a coefficient, number in front of a variable. A is going to be the number in front of your x squared. B is going to be the coefficient of x. C stands for constant. Doesn't have a variable attached to it. So A is your number in front of x squared. B is the number in front of x. C is the constant tagged onto the end. So what you're seeing that I highlighted in the answers to your warm-up are your c values here at the end, and then your ax squared values. So what you see are all of these, in every single answer you did in your warm-up, those are quadratics in standard form. They're the result of foiling, right? Our mission for today is to go backwards, so our problems are going to very much look like the answers to your warm-up, and our mission is to just stuff these 2 binomials here. So we got to work backwards through the FOIL process to get those binomials. I'm just going to start with what I think you remember, here in example 2, actually. Here in example 2, you are factoring a trinomial where your leading coefficient is not 1. And I'll make that a little bigger so you can see. You folks know this as AC grouping. My daughter's teacher has this cool little thing. I was like, oh, I might steal that. She calls it the AC bust up B method. Have you heard that?
No. The what? Say that again?
Heard it here first, kids. So you folks, you've heard of AC grouping?
Yeah. Did you do example 1?
No.
Is it like b squared minus 4ac or something?
That's a discriminant. Fancy. No, the b squared minus 4ac comes at us in the quadratic formula a little later. But another way of looking at this, if you thought of it as AC grouping, that's fantastic. But her teacher says it's A and C get together and they bust up B. So let me talk to you about what that means. Our mission is to take what is 3 terms and turn it into 4 so that we can group it. So how do we take these 3 terms, and when I say 3 terms, I'm talking about 1, 2, 3. How do I take these 3 terms and turn them into 4? Well, we put A and C together, and we're going to bust up or turn that 17x into 2 terms. So A and C get together to bust up B. That's what we're going to go ahead and do. I was like, oh, that's kind of user-friendly. So when I look at the problem, again, going back to what I just taught you, what is the A value in this problem?
6.
It is, it's just the 6.
6.
It's a coefficient of x squared. What's C? 5. Okay, and then in order to figure out the number we need to use to bust up B, we just multiply A and C together. So 6 times 5, put those together. Yes. Okay, now we can use these two numbers to bust up b. So what we have to think about in step 2 are the factors, in other words, the things we could multiply together to give us 30 that add to b in the original expression. So when I'm thinking about this, I'm thinking about 30, but in the back of my head, I'm like, okay, well, what multiplies to give me 30? This is me thinking. Here's my little thinking cloud for my notes. I'm thinking, what multiplies to give me 30, but then adds to positive 17? Royce.
2 and 15.
2 and 15. Brilliant. 2 times 15 is 30. 2 plus 15 is 17. Everybody okay so far? Let's go. Okay, so how does this now bust up b? Okay, what we can do in step 3 is start to copy our problem. So 6x squared is going to stay. You can put that away, Jaden. 6x squared can stay. We busted up b by, I'm going to attach an x to the 2x and the 15x. So 17x now becomes plus 2x plus 15x. And then we have that plus 5 at the end. So do you see how b is now broken into 2 separate terms? A and C got together and they busted up b. So 17x is now replaced with 2x and 15x. In algebra, super important idea, big idea in algebra, is just preserving equivalency, right? You should never be writing something that's logically unequivalent to the original problem. So what we have in this 4-term polynomial expression, 6x squared plus 2x plus 15x plus 5, is an expression that's logically equivalent to our original problem, 6x squared plus 17x plus 5. They're the same thing. Okay, so now we group. We group because, and I'll go ahead and let you know, we already have done the GCF method. So this is how yesterday's lesson sort of comes in a little hot on you here. So I'm going to go ahead and now use this factoring by grouping method. Some teachers get real fancy with the notation. I just kind of put a squiggle down the middle of my problem, like that. And then what I'm going to go ahead and do is GCF this first part. In other words, think back to last night's assignment. What is the greatest common factor between 6x squared and 2x? 2x, is that what you were going to say over there?
2x.
Yeah, legit. Nice. So we got 2x times what gets us back to 6x squared?
3.
Yeah, 3x. We need one more x too, yeah. And then 2x times what gets you back to 2x? That's just times 1. Okay, on the right side of that squiggle there, we now need to GCF 15x plus 5. Yeah. And then we ask ourselves 5 times what? Gets us back to 15x in blue there. It is 3x. And you should notice a startling pattern here. And then 5 times 1 gets us back to 5. You see this? It's amazing. This 3x plus 1 appeared magically over here too. That always must happen, FYI. Those two parentheses always need to match. There's actually, it's so important there's a term for it. It's called the repeating binomial quantity. And it's actually a greatest common factor in the polynomial you see before you. So I could actually put like a plus sign in between these things. Oops, grabbed the wrong thing. So a little plus sign in there. And 3x plus 1 is now a GCF all on its own. So I can pull it out. Check it out. So this 3x plus 1, see how it repeats? You bring that one down. I'm going to pull it out of the problem. And since I pulled it out of the problem, I can get rid of it. And then I have to bring down what I have left over, which is a 2x and a plus 5. So I actually GCF'd 3 times. I GCF to pull the 2x out, I GCF to pull the 5 out, and I GCF to pull the 3x plus 1 out.
So, since 3x plus 1 appears twice, would it be 3x plus 1 squared?
No, because it's the greatest common factor. That's what I'm saying.
Oh,
Like, check it out. The idea would be, if you wanted to, we could take this 3x plus 1 and distribute it to 2x. That gives you this piece right here. You could also take 3x plus 1 and distribute it to 5. That gives you this piece right here.
I see.
So it's a lot of students do want to write it down twice, but because it's 3x plus 1 is a greatest common factor, you only pull it out one time. It's like saying like, oh, should I have pulled 2x out twice here? No, it's only in one time. So yeah, you just see the thing that repeats, just bring it down and write what you have left over. You won't mess it up that way. Okay, and then you also won't mess it up because I'm going to make you check. We check with FOIL like we did in our warm-up. So, you know, you do your F, your O, your I, your L, and you hope you get the right answer.
Wait, there's an entire thing for it? No.
So we're going to check with FOIL. So we do 3x times 2x. That's 6x squared, so that's good. My outers is 3x times 5, so that's 15x. My inners is 1 times 2x, that's 2x. My last is 1 times 5, that's 5. And then if I put all this together, I get the original problem. I have 6x squared plus 17x plus 5. So that checks, which means this guy right here is my correct final answer. It's a little review of AC grouping for you. So let's retrace our steps real quick before we try a couple more. The next part of our lesson doesn't have like the cute little boxes, so we kind of have to like do it like we would on our homework, right? Okay, so the first step is we multiply a times c. So if our quadratic is written in standard form, a is again the number in front of x squared, c is the constant at the end. And then you use that product of AC to bust up b. So if a times c was 30 in this case, I had to look at the b value of 17 and break it into 2 terms. Because 2 and 15 add to 17 and multiply to 30, the 2 terms I busted up b into was 2x and 15x. So then I rewrote my polynomial and I grouped it. So you take your 4-term expression, you split it down the middle, and you GCF a couple times. Chickadee check yourself with FOIL, kids. All right, this is what we're doing today. We are AC bust up B or AC grouping. I don't have my blank example 3. So here in example 3, we're going to AC bust up B to go ahead and factor 2x squared plus x minus 6. And we should acknowledge why all of a sudden we can't use the shortcuts from yesterday. Does anybody know why I can't just like jump right in and use my square root method on this, my GCF method? A couple of you do. Go ahead, Jaden.
Because the c value is negative?
Right. Jesse? 2 is also prime. If you square root 2, you get a headache. Same thing with 6, because it's a product of 2 prime numbers also. Yeah, so square rooting 2, square rooting 6, not fun. And yeah, if we're going to use the shortcut, that last symbol always needs to be a plus sign. So that's a good detail that Jaden brought to our attention. There's also no greatest common factor in these, like x doesn't have a 2 or an even number in front of it. So at this point in time, you're just stuck. Like you have to use your AC bust up B method. So I'm going to go ahead and do A times C. And that's 2 times negative 6. And that's negative 12. And then I'm going to use this AC value to bust up B. So B in this case is that 1x. I need to break this positive 1x into 2 terms. Okay, anybody know what I'm going to break it into? Go ahead, Royce.
Positive 4 and then negative 3.
Yeah. Okay, you were very specific about the signs on that. Why does it have to be positive 4 but a negative 3?
Because the x has to be positive. And if it was negative 4 and positive 3, then it would be negative x.
Yeah, then you would have a negative x. Good job. So, yeah, you need the positive 4 and the negative 3 because it has to make positive 1x. 4 minus 3 is positive 1. So, yeah, we actually have to turn this not into 1, though. We have to turn it into 1x. So I'm going to rewrite my polynomial with now the busted up version of b. Just bringing down my 2x squared from right there. Then I got to bring down my minus 6. So now you have this 4-term polynomial expression that is logically equivalent to our original problem. And now that we have 4 terms, we can group. All right, so we got 2x squared plus 4x. So you got to pull your GCF out of there. Yes, very good. And an x, huh? So we got 2x, and this would give me x plus 2 left over. And then you could pull the negative 3 out. And you'd once again have your x plus 2 left over. You see the repeating binomial quantity hiding there? See how they both have the x plus 2?
X plus 2 squared.
No squared. You just playing. You got me good on that one. I was like, no, dude. What's wrong with you? All right, so x plus 2. You bring that down. What's up? Make fun of me.
No.
I'm coming for you. All right, so since we bring the x plus 2 down, we don't need it anymore. We just write what we have left over. We got a 2x, wrong color. 2x minus 3 is what we have left over here and here. All right, you're all probably as anxious as I am, like, did this actually work? And honestly, like, except for your quizzes, I don't make you show your check, but it's always a good idea to do it, right? So even if you just do it in your head real quick, you know, x times 2x is 2x squared. Negative 3x and positive 4x, ding, 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 makes 1x. And then positive 2 times negative 3 gives us negative 6. So it is good. Makes me happy. I like when I get the right answer. So that's how I'll see students set up their responses on their homework. What's up?
Do you want us to write like all the factors out, or can we just go to listing them? Like the ones that would add up to the middle term?
Oh, no, you don't have to list them out. Let me be honest with you, Jesse. You bring up an excellent point. So we're going to practice this a little bit more on Monday. And your weekly agenda for next week did post, you know, we're all ultimately getting ready for a factoring quiz. I will have students say, you know, like, I just can't factor this because I can't think of the numbers. So before I help a student, I will make them list all of the factors before I swoop in and fix the problem. Like, I'm not going to tell a kid, like, oh, it's these 2 numbers. Because I think if you just put the pencil to the paper and you're a little tenacious and scrappy with it, everybody can find the 2 numbers that would add to the B that multiply to AC. So if you can't find the numbers, you just got to find the numbers. You can use a calculator, but you got to find them. Okay, that's a great question. Thank you, Jesse. Any other questions about this one? No, none? Okay. Now another slide showing you the answer there. Oops. Oh, and that is... You like a shortcut? Okay, so we are going a little out of order in the notes. I know that that's a little bit unnerving. We're scrolling back to example 1. So at this point in the notes, we've done example 2, example 3, and the warm-up. The shortcut comes at us when we have an easier problem, and that's why we're back at example 1. If you know how math teachers work, usually the examples get harder as you go through a lesson, and then the homework also works the same way. The assignment gets harder the deeper you get in. So we're cycling back to an easier problem because that's what we have a shortcut for. And you might be saying, well, what makes this problem easier? Well, the fact of the matter is that the leading coefficient is 1. In other words, that's fancy talk for, see this x squared right here? It's all by itself. There's no number in front of it. So when there's no number in front of your x squared, in other words, when your a value is 1, you don't even need to do all out AC. You can just think of the things that multiply to C that add to B. Exactly. So instead of all out doing A, C, you're just using C to bust up B. But it gets easier than that even. So the numbers that multiply to 12, and right now I'm thinking about my B value. Here's me thinking. I'm thinking about my B value of -7. I'm like, okay, well, what multiplies to give me 12 that adds to -7? And somebody said it. What was it? Where was that? Yeah, what was it?
-3, -4.
Yeah. -3 times -4 is definitely positive 12. And then the sum, if I add -3 and -4 together, I do get also -7. Okay, remember from the warm-up today, I'm trying to teach you that we're just stuffing 2 sets of parentheses, right? So automatically, -3 and -4 go in your parentheses right there. And then you're just left with one question. You know, what do you multiply together to give you x squared? What 2 things multiply to give you x squared? Think back to your homework last night. X times x. So I basically just unfoiled that problem. That's a little shortcut. So just look at your C values. Figure out what multiplies to give you C that adds to B. Plop those in your parentheses with an x. Because if it's just x squared there, x times x is what's going to give you x squared every time. Keep in mind this shortcut only applies when you have just an x squared at the front of your problem there. You want to try the shortcut? See how it goes.
Does that work every time?
So it's a shortcut for a special type of problem. The special type of problem is if it's just an x squared. The visual difference between what we were just doing and this is that the problem we just did had like 6x squared in it. So if there's a number in front of that x squared, you can't use this shortcut. Because if you think about it, we're foiling, right? X times x gets us x squared. But if we put a number in front of the x squared, there needs to be a number in front of these. And that's why you have to use AC bust up B when there's a number in front of the x squared. Does that make sense? Okay, so now you guys get to practice for a hot second. You have some independent practice problems for me. All right, here's your independent practice problems. All of these are going to be AC bust up B. But remember from a couple days ago when I taught you, the first method you should always try isn't AC bust up B. Does anybody remember from yesterday's lesson, that conclusion question? What method should you always try first?
GCF.
Yes, GCF method, very good. So one of these you have to GCF first before you do AC bust up B. All right, ready, set, go. All right, answers to your independent practice. I'm worried about part C if I had to pick. Remember, you got to GCF it first, so you had to pull the 2 out, and then use your AC bust up B technique.
You couldn't AC A?
You could AC bust up B A, yeah.
I mean, I tried. I couldn't really.
I just did that one in my head, actually, which is, if I could get into how to do those problems even quicker, I will do that on Monday as well.
Can you go over A?
Yeah,
That's weird.
sure. Happy to. So, again, AC bust up B on part A. I would do 2 times 3. I think last time I checked that was 6. And then I'm trying to bust up this B value, right?
Oh, yeah, I literally forgot that method.
Yeah, so we got to do the negative, oh my gosh, I'm not writing the right number. We got negative 3 and a negative 2 will actually add to negative 5 there in between. And then I'll attach x to these. And then I'll bring down from the original problem that front term of 2x squared and that back term of positive 3. So now I have my A and C that busted up my B. So I'll go ahead and GCF my way to a correct response. So I'm going to pull out an x. And then it looks like what I'll have left over is the 2x minus 3. And then on the other side, you got to pull out a negative 1. Remember, whenever you have that negative leading coefficient, you got to pull out a negative 1. And then that'll leave behind your 2x minus 3. So that repeating binomial quantity, always there. See how it repeats? Jaden's not going to mess with me on that one. I thought he totally was. All right, so we got 2x minus 3.
I wasn't paying attention. I literally forgot the AC crew after like 5 minutes after doing it.
And then we have, so those things undo each other, and then you have x minus 1 left over.
I do like that guy.
So that's how we got that answer. Any other questions on your independent practice? Nice job, people. Nice job. So we'll do grouping, finish up the notes on this lesson when we get back together on Monday. And that's it.